So as we saw in the last example, the more times you compound in a year, the more money there was in the account at the end, right? So compounding semi-annually got you more money than compounding once a year. And then compounding 4 times a year got you more than twice a year. And compounding 12 times a year got you more than 4 times a year, right? So then you might be thinking, well, the more you compound, it's just like infinite, right? The more times you compound, it's just an infinite amount of money that you can get. But there is a limit to it. And that's what we're going to look at in this example. So you're starting with $1 and it pays a 100% annual interest rate, right? So that would be the formula given that information that we've looked at, right? Where 1 is what you're starting with. There's always the 1 in the B value plus the percentage. 100% as a percentage is 1. And then we're going to divide it by n, right? Because n is the number of times we're going to compound. And then we're also going to multiply the exponent by n. All right. So what we're going to look at here is if we keep increasing the amount of times that it compounds in that 1 year, what's the effect on the end result of the money? So if it's not compounding at all, you get 100% interest rate. You're holding $1 all year. And at the end of the year, you get 100% of that $1 added to your account. So that's why you end up with 2, right? If we compound it 3 times, you end up with $2.37. $4 times, $2.44. 5 times, $2.48. Keep going, right? And the effect is, yes, we're increasing the exponent, but you're also dividing the rate. So that it's going to end up balancing out. As you can see, it's kind of like a steps function here. If we compound 10 times in a year, you end up with $2.59. What about 20 times? $2.65. How about 100 times? You end up with $2.71 if you round. How about 1,000 times? $2.72, right? So you see how the amount that it's increasing is dropping. There's a limit to this. If I just pull it all the way out to 100,000, it's $2.72, right? So it increased a lot quicker at the beginning, right? And it's kind of leveling off here as you get out to bigger numbers. So that's the whole point of this, right? Is that there is a limit to the amount of times the impact that continuously compounding that interest is going to have an effect on the amount of money that you'll have at the end, right? Just compounding it 10 times got you $2.59. 100,000 only gets you an extra 12 cents, right? So compounding 10 times added 59 cents of value compared to not compounding at all. 100,000 times added only an additional 12 cents. Okay, so now let's look at some definitions in order to kind of understand what's happening here. So the natural base E is defined as the value that the expression approaches as x approaches infinity. So as the number of times you compound approaches infinity, we end up with this value of E that is an irrational number. Okay, so that's essentially what the base is going to be. So what we can do is use that base in the formula. So it's a separate formula for if we're going to compound continuously. P is the amount of money you start with, principal. E is that natural base. So it's this irrational number. E, think of it as the next most famous irrational number after pi, right? Pi is definitely the most used. E would be the next most used. It is an irrational number. Round it to this. E is on your calculator, and we can talk about that in class if you have questions about that, about how to use your calculator there. A is that the next, the amount of money that you're going to have in your account after T amount of years. T is the amount of years, and then R is the interest rate. So it's a similar formula, but you're using E. All right, and again, you can pull E off your calculator. So what we're going to do, well, we're going to use 1 million as your value of N. Is that going to increase or decrease the amount? Well, if you just look at the pattern, these numbers keep increasing, right? It's never going to curve back down. So it's not going to decrease. Would the amount in the account increase? Yes, but only a tiny bit. So let's actually calculate that. You can use a scientific calculator. So here, well, let's write it out first. Then I can go over how to put it in the calculator as well. So if this was 1 million, the way the formula would be written is 1 plus 1 over 1 million raised to the power of 1 million. So this means it compounds 1 million times in a year. So what we're going to do is we're essentially going to try to type this into the calculator. And I'll show you the best way to do that. Okay. So 1 divided by a million. Raised to the power of 1 million. And we end up with 2.71828. And that's where the increase is happening, in the 5th decimal. All right, so it is increasing. It's just the amount that it's increasing is starting to get smaller and smaller and smaller. All right, let's look at example 4.